let's kick things off by imagining a scenario so absurd it could only exist in the realm of physics textbooks and science fiction movies. Picture this: a humble golf ball, the kind you might find on your local course or in the hands of a pro golfer, is somehow launched at an astonishing speed, nearly the speed of light. That's 299 million meters per second, which is so fast that it would take just over a second to travel from Earth to the Moon. Now, imagine this tiny ball hurtling through space toward our nearest celestial neighbor, the Moon. This isn't just any golf ball. It's a cosmic projectile with a mind of its own, and we're about to explore what happens when it smacks into the Moon. But wait, before you start picturing a dramatic collision scene like in a blockbuster movie, let's take a step back. The speed of light is the ultimate speed limit in our universe, according to Einstein's theory of relativity. So, if this golf ball were actually moving at 299 million meters per second, it would be traveling at almost that exact speed. That means it's not just fast, it's practically a light beam with a little bit of mass attached. Now, imagine the Moon, which is about 384,400 kilometers away from Earth, being hit by this tiny but incredibly fast object. What could possibly happen? Well, let's break it down. First off, we need to consider the physics behind such a collision. At these speeds, even the smallest object can pack an enormous amount of energy. In fact, the energy involved in this hypothetical scenario would be so immense that it could potentially create a massive explosion or even trigger some kind of cosmic event. But before you start thinking about apocalyptic scenarios, let's remember that this is all theoretical. The golf ball isn't actually going to hit the Moon anytime soon, unless we're talking about a science fiction plot where physics rules are bent for dramatic effect. Now, let's think about what would happen if such an event did occur. The golf ball, traveling at nearly light speed, would collide with the Moon in an instant. The impact would release an incredible amount of energy, far surpassing any natural or man-made explosion on Earth. This energy could cause massive destruction, potentially creating a crater so large it would be visible from space. But here's where things get even more interesting. Due to the extreme speed and mass-energy equivalence, the collision might not just create a crater. It could also generate powerful shockwaves that ripple through the Moon's surface and possibly even affect its orbit. However, there's another angle to consider. The Moon is made up of rock and dust, so when this golf ball hits it, it would essentially be like a tiny meteorite slamming into a massive celestial body. But instead of being a slow-moving meteorite, this one is moving at nearly the speed of light. That means the collision would release an amount of energy comparable to a nuclear explosion, though not quite as destructive as a full-scale atomic bomb. Still, it's enough to make even the most seasoned astrophysicists scratch their heads and wonder what kind of cosmic chaos could result from such an event. Alright, let's talk about something that sounds like it belongs in a sci-fi movie: traveling at nearly the speed of light. If you've ever watched a space adventure or read a physics textbook, you might have heard terms like time dilation and length contraction. But what do they really mean? Well, imagine you're on a spaceship zipping through the cosmos at 299 million meters per second, just a hair slower than light itself. From your perspective, time would start to behave differently compared to someone watching you from Earth. That's time dilation for you, and it's one of those mind-bending concepts that makes physicists go, whoa. Now, let's break this down with some real-world examples. If you were traveling at such a blistering speed, your watch would tick slower compared to someone on Earth. This isn't just a trick of the light or an illusion. It's a fundamental aspect of how the universe works when you're moving at relativistic speeds. Time itself becomes relative depending on your frame of reference. So if you were to return from your journey, you'd find that more time had passed on Earth than for you. It's like being in a time warp, but without the need for a DeLorean or any sort of portal. But wait, what about length contraction? That's another wild effect that comes into play when you're moving at near light speeds. From your perspective, the universe around you would appear to shrink in the direction of motion. Imagine looking out the window of your spaceship and seeing stars and planets compressed like a photo developed in a hurry. This isn't just a visual trick. It's a real physical phenomenon predicted by Einstein's theory of relativity. The faster you go, the more contracted the space around you becomes, making distances seem shorter than they actually are. Now, here's where things get even stranger. If you were to travel at such speeds for any significant amount of time, your mass would also increase. This isn't just a matter of getting heavier. It's about how energy and mass are related in the universe. The faster you go, the more energy you need to keep accelerating, which means you'd require an astronomical amount of fuel to even get close to light speed. In fact, reaching the speed of light would require infinite energy, which is why it's considered a cosmic speed limit. So, What does all this mean for our original question about a golf ball hitting the moon at 299 million meters per second? Well, if that were possible, the physics we've just discussed would come into play. The golf ball wouldn't just hit the moon, it'd experience time dilation and length contraction in ways that defy our everyday intuition. It's like watching a movie where everything is slowed down or stretched out, depending on your perspective. And while this might sound like something from a science fiction novel, it's actually grounded in real physics. Just don't expect to see it happen anytime soon. Alright, let's imagine this absurd scenario where a golf ball is somehow launched at the moon with a speed that's almost exactly the same as the speed of light. 299 million meters per second. That's not just fast. It's like the golf ball is trying to outrun time itself. But wait, even if we could achieve such a velocity, the moon isn't some soft target waiting for a cosmic swing. It's made of rock, dust, and a whole bunch of ancient craters that have been there since the solar system was still getting its act together. Now, when this golf ball slams into the moon, it's not just about the impact, it's about energy transfer. The kinetic energy of the golf ball is so immense that it would be like throwing a nuclear bomb at the moon and then watching it explode in slow motion. But here's the catch. The moon has no atmosphere to slow down the golf ball, so it hits with all its might, unleashing an explosion of energy that could potentially reshape the lunar surface for millions of years. The energy from this impact would be distributed across the moon's crust like a cosmic shockwave. The ground would crack and crumble under the force, creating massive fissures and maybe even triggering small earthquakes deep within the moon's interior. But don't get too excited, this is all hypothetical, right? Well, not exactly. If we could somehow achieve such speeds with a golf ball, it might be enough to create a crater so big that it would rival the size of the largest impact craters on Earth. Of course, in reality, this scenario is impossible due to the sheer amount of energy required and the physical limitations of our current technology. But even if we could somehow make it happen, the moon's surface would be left in a state of chaos. The golf ball wouldn't just leave a dent. It would cause a chain reaction that might even affect the moon's orbit or its magnetic field. Imagine the moon being hit by a tiny, fast-moving object and having to deal with the aftermath for eons. So, while this is all very entertaining to imagine, it's also a reminder of just how powerful energy can be when transferred at such high speeds. The golf ball might seem like a harmless little sphere, but in the context of space, even the smallest object can have massive consequences. It's a fun way to think about physics and the scale of things in our universe, where even a tiny golf ball could cause a cosmic catastrophe. Okay, so imagine you're swinging a golf ball like it's the most important thing in the universe. Now, instead of hitting a tee, you're aiming for the moon. Only this time, your swing is so powerful that the golf ball isn't just moving fast. It's moving at 299 million meters per second. That's almost the speed of light. And here's where things get weird. When something moves that fast, Einstein's theory of relativity starts to play a major role. Time slows down for the golf ball relative to someone standing still on Earth, and space itself gets stretched out in the direction it's moving. It's like the universe is stretching its arms to say, "Whoa, that's one fast golf ball." But wait, what does this have to do with the moon? Well, if our golf ball is traveling at near light speed, it's not just about speed, it's about mass. According to Einstein, as an object approaches the speed of light, its relativistic mass increases dramatically. So that little golf ball, which weighs next to nothing on Earth, could become a massive object in spacetime. And if it hits the moon at such speeds, the energy released might be enough to create gravitational waves, ripples in the fabric of spacetime itself. It's like throwing a pebble into a pond, but instead of ripples on water, you're creating disturbances that can travel across the universe. Now, here's where it gets even more mind-bending. If our golf ball is moving so fast and has such a high relativistic mass, there's a chance it could create a small black hole upon impact. Black holes are regions in space where gravity is so strong that not even light can escape. But how does a golf ball turn into one? Well, the energy from the collision might be enough to compress the matter in the moon's crust or even the surrounding spacetime into a tiny region with such intense gravity. It's like if you took a feather and somehow compressed it into a pinhead. Suddenly, that feather becomes a black hole. Of course, this is all theoretical, but it's fascinating to think about what happens when physics meets golf. But let's not get too carried away. The moon isn't just sitting there waiting for a golf ball to hit it. It's actually moving through space at its own speed, orbiting the Earth. So if our golf ball is traveling at near-light speed toward the moon, their paths might never cross unless something changes. And even if they did collide, the energy involved would be so immense that it could potentially alter the moon's trajectory or even cause a massive explosion. It's like if you tried to hit a moving target with a bullet that's going faster than anything in the universe. Except this bullet is a golf ball and the target is the moon. So what does all of this mean for us? Well, it shows how incredible the power of relativity can be. When objects move at near-light speeds, they don't just break speed limits, they bend space-time, create gravitational waves, and might even form black holes. It's a reminder that the universe is full of surprises, and sometimes the smallest things, like a golf ball, can have the biggest impact when they're moving fast enough. Imagine a golf ball, that tiny little sphere you hit with a club on your backyard course, hurtling through space at a speed so fast it's practically cheating physics. At 299 million meters per second. Yes, that's the speed of light. It would be like throwing a pebble into a pond and watching the ripples spread across the entire universe in an instant. But wait, this isn't just any golf ball. It's one that somehow managed to escape Earth's gravity and head straight for the moon. Now, picture the moon as a giant, ancient rock with craters from millennia of space debris slamming into it. If a golf ball hit it at light speed, you'd think the moon would just explode? Not exactly. The shock wave from such an impact would be like a cosmic tsunami, but instead of water, it's pure energy and radiation. This wave could potentially shake the moon's surface so violently that it might cause massive quakes, maybe even trigger landslides on its far side where no one is watching. But let's not get too carried away with the drama. The moon isn't just a rock. It's part of a delicate dance in space. It orbits Earth every 27 days, and that orbit is pretty much perfect for keeping things stable. If this golf ball hit the moon at light speed, the energy released would be enough to send shockwaves rippling through its crust, maybe even altering its orbit slightly. Think about it like a tiny asteroid hitting a massive planet, except in this case, the asteroid is a golf ball and the planet is the moon. The impact could cause the moon's orbit to shift, which might have ripple effects on Earth's tides and even our climate over time. It's like if someone suddenly changed the rules of a game without telling anyone. It would throw everything off balance. Now, let's take it one step further. If the shockwave from this golf ball hit the moon with such force, it might not just affect the moon itself. It could also send ripples through space. The solar system is a vast and mostly empty place, but even in that emptiness, energy can travel. This shockwave would spread out like a cosmic ripple, potentially affecting nearby asteroids or comets. Imagine a chain reaction where one tiny impact sets off a series of events across the solar system. It's like dropping a pebble into a pond and watching it create waves that eventually reach the other side of the world. In this case, the pebble is a golf ball and the pond is space itself. But here's where things get even more interesting. The energy from such an impact could also influence the magnetic field around the moon. While the moon doesn't have a strong magnetic field like Earth does, it still has some residual magnetism from its past. If this shockwave disrupted that field, it might affect how charged particles from the sun interact with the moon's surface. This could lead to changes in the way solar winds hit the moon, potentially altering the environment for any future lunar missions, or even affecting the moon's ability to retain certain elements like helium-3, which is a potential fuel source for fusion energy. And let's not forget about the broader implications for space exploration and our understanding of physics. If a golf ball could cause such massive effects at light speed, what would happen if something bigger, like a meteor or even an asteroid, hit the moon? The consequences could be catastrophic, not just for the moon but for Earth as well. Imagine a chain reaction where one impact triggers another, and so on, creating a domino effect across the solar system. It's like a cosmic game of Jenga, where one wrong move could bring everything crashing down.